So hello guys and welcome back to another video of mine. So today what we're going to do is we're going to be solving this particular LeetCode problem. This problem is an easy problem called move zeros, and most of us would be easily doing this with using Python list functions very easily. But today we're going to be thinking about it in a little bit different way, and we are going to come up with one more much more efficient solution to this problem. So let us start by understanding the problem. The problem goes like this. We're given an integer array of nums. We have to move all the zeros to the end of it while maintaining the relative order of the non-zero elements. So we can look at an example. The example goes like 0, 1, 0, 3, 12. So what we have to do is we have to move each of the zeros to the end and we have to push the rest. So 1, 3, 12 and rest zeros here. So if you think about it, it is actually quite easy. So we're going to be looping through this list once, and if we see a zero, we will remove it from here and add it to the end. Then if we see a 0 again, we will remove it from here and add it to the end. That is all we have to do. So it's actually quite easy. So let us try that with the help of some Python functions. So we're going to loop through the elements for n in nums if our n equals 0. That means we are checking if that number is 0. If that number is 0, what we are going to do is nums dot remove n. First, we will remove it from the list, and after that, we will append it. Nums dot append ent. That number we'll just append it. The rest we don't have to do anything. So we can just run our program and test it. We do not have to return anything. That is why I didn't return anything. So it is passing the test cases. So let's try to submit it. So we have done our program and it is not that efficient. So the program was submitted, but it is not that efficient. So next we're going to think of another way to do this same problem. So we're going to approach this using the two pointers. So we know how to do the two pointers and I'm going to give a small example. So I'm going to share this list, copy, and we can just paste it here. So this is our list. So what we are going to do is we'll have two pointers. So in two pointers we'll usually call it as left and right. So I'm going to call this as left. Okay, I'll have to increase the size. I'll have to 0, 1, 0, 3, 12. So this is our list, comma, 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 comma. So I have a left pointer and a right pointer. So what I'm going to do is instead of taking all the zeros to the right, I'm going to say I'm going to take all the numbers to the left. So what we are left with is the zeros to the right. It's actually quite simple. So think with me. So what I'm going to do is if I have a non-zero number, if I have a non-zero number, that means at first both of them will start at the same point. Our left and right will start here. So right is at 0, so I'm not going to do anything and I'm just going to go to the next. So my right will now come here. So we have 1. 1 is not a no 0. So what we are going to do, we are going to swap this with the left. So after swapping, what happens is 0 1 will become 1 0, and the rest is same 0, 3, 1, and 2. And what we'll do is after doing that, our left will jump one point forward. If a swap has occurred, our left will move because our left should always point to a 0. So our left was here, so our left will move here. And then our right will move here. And then our right will check if it is a 0, we'll just ignore it. And our right will move to the next position. And our right is here right now. So we have a 3. 3 is not a 0. So what we'll do, we are going to swap. So after swapping, it will be 1, 3, 0, 0, 1, 2. So if we swap, our left pointer should jump. So our left pointer will come here and our right pointer will move one step forward. Our right pointer will move one step forward means our right pointer will be here. So it is not again a 0. So we'll have to swap it. And our 1 will come here, 0 will come here. So it will become 1, 3. Okay, it is not 1, it is 12. 12, 0, 0. So at the end, we got all the zeros to the right side. It is actually quite simple. I'm going to explain it once more. So what we are going to do is we'll have a left pointer and a right pointer, and our left pointer will always be pointing towards a 0, and our right pointer will move along the array, and if it has a number, and then it will swap with the left pointer. So we can do this in a much more efficient way. So the last time when we submitted, we know that our runtime was quite big. It was 820 milliseconds. So let's try to do it in a much more efficient way. So what we are going to do is again loop through it for. So okay, I'll have to have my left pointer. My left pointer will start at 0, and for r in a range len of nums. So what I did here is to loop through every element of the list. That is, I will loop through the range of the length of the array. And at the beginning, both L and R will be at 0. And if nums of R, nums of R means the R pointer in the nums is not 0. Is not 0 means we'll just have to do this. We don't have to equate it because Python treats 0 as a false. So if it is not 0, what we are going to do? I'm just going to swap nums of R, comma, nums of L equals nums of L, comma, nums of R. This is an easy way to swap elements in Python. It is used quite vastly. And after that, what we have to do? Every time we swap, we'll have to increase our left by 1. So that's the code. It's very easy, and let's try to run it to check if there are any errors. So it works, and let's try to submit it. It had a far superior runtime. Our other one was 800 millisecond, and this ran in about 131 millisecond. So that's it, guys. Thank you for watching, and I'll see you guys again in another video.